Neither. All right. So I'm pretty sure we did one at least like this, if not this one exactly. So what form is this in currently? If you try to plug an 8 in, what form do you uncover? 8 minus 8 is 0.
Over infinity.
Natural log, as something goes to 0, is going to go to negative infinity. So that's indeterminate. So you have to kind of know what your indeterminate forms are. Because if it's not indeterminate, that means you should be able to get the answer immediately. So it's kind of important to know what's indeterminate and what isn't. We know for sure this is, and we know for sure this is. Well, if I take that and reciprocate it, it becomes that. If I take that and reciprocate it, it becomes that. So that is one of those two. Just depends on which way you want to go. Since L'Hopital's involves taking derivatives, I probably don't want to do a reciprocal natural log. I could, but my God, I don't want to. So I'd rather probably reciprocate that underneath. Why do I have to do that?
Because you can apply that as
Yeah, L'Hopital's is hardwired to work on ratios. That's the whole idea that it captures. So I have to be able to write my thing, my indeterminate form thing in a ratio. Cool. You guys with me? A little bit? You guys here? Am I dreaming? Okay. Let me turn around and be alone. I'm like, has this been the whole semester like this? Everybody's worried about you, Jeff. Alright. Now somebody out there's like, do I exist? So if I make it look like that, and one thing you have to be comfortable with is the fact that you can do this. This is completely legal to do. It's true. It's just the truth. And now I can attack it with L'Hopital's. Because now it's officially in...
ratio.
Sure, it's a ratio. But which one? It's like this one, right? I know one is a negative, but who cares? Cool. I thought for sure we did this one. So if I do L'Hopital's, what happens?
1 over x minus 8.
Oh yeah, that's right. We did one almost just like this.
Yeah.
So it didn't have the minus 8, but it's going to work the same way. So 1 over x minus 8. And what's the derivative of 1 over x minus 8?
Negative 1 over x minus 8 squared.
Yeah, negative 1 over x minus 8 squared. And this is beautiful now. This is beautiful. Let it be beautiful. Multiply by the reciprocal. 1 over x minus 8 is going to cancel. Do you guys see that happening?
Yeah.
So division by this is multiplication by this. One of these cancels. When you plug an 8 in, you get 0. So, if I'm you and I'm having trouble in a problem like this, and I'm letting you use your calculator, graph this. Get a feel for what the hell's going on, so you can at least know what the answer looks like it's going to be. Don't then say, well, my calculator looks like it's... Well, no, screw that. You're just going to make me angry. And you don't want me to. Yes?
What was that last one? Multiply by
Here?
Yeah.
Oh, division by something is multiplication by its reciprocal.
Right.
So I just rewrote this as its reciprocal.
Right.
Okay, cool. I like it. So yesterday I think we did one without a minus 8 in it. It's just an ln x. And that's going to work the same way. This is linear in x. So that's the same function, to be honest, in a very real way. It just moved. But who cares? I can put my coordinate system wherever I want to for a lot of things. So that doesn't really change it fundamentally. Okay.
13, 25.
We'll get there. So were there any other specific questions before I jump into like number 7? I just want to do the ones out of the book since I didn't have time to make the answer key for those. Number 7, we go back to page 353. I think, what was the one we already did? 52... No, I did that with somebody. I don't think we did that together, did we? 58, I think, is the one that I had on an earlier practice test. All right. Has anybody tried that one out? By any chance, 52? Yes? Yeah, I think, was it you and I were talking about that one? Right? Okay. So it says find the point on this that is closest to the point 30. What does that look like? No. You don't have to worry about all that. You can just solve for y, right? Yeah, so this would, if I look at this and solve for y, I get this. So what does 1 over x look like? Quick sketch. Draw in the air. What's it look like? Yeah, it looks like, right? Draw. So all the 8's going to do is make it rise quicker, right? Maybe make everything kind of 8 times what it used to be, but it's still going to be in this shape. And so I want to know the closest to the point 30. Well, it's going to be something around over here. Now, does that help me get the exact answer? No, but it kind of grounds me in what the hell is this problem saying? Well, this hyperbola, where does it get closest to the point 30? So I can see it now. I feel a little bit more like I know what the hell this thing is trying to tell me, what it's asking. Maybe. So what is it I'm trying to do? This is some kind of an optimization problem. Find the point that is closest to the point 30. So how can you put that in the form of minimize or maximize the blank?
Distance equals square root.
So if I want to get closest to something, I want to minimize the distance. Now, please, if I can say minimize the blank, like minimize the cost on that one problem on the test, with the thin side lengths and so forth, then you focus all your attention on creating that function. Because you can't do shit until you get that function created. They're not going to attack it with derivatives, set equal to 0, do all that magic. Right?
Which number is this?
Number 7, number 52. Yeah, part 7 goes back to the book. So how do I set up the distance formula? Well, give me a point that's on this, not a specific one. Give me every point that's on that. What's that point? Don't be specific. That's the point x, comma.
F of x? Or 8 over x?
8 over x. Cool. That's what that point is. Right? If I said what x for 1, what's the point at 1? 1 comma 8. So whatever input you provide, the output's going to be 8 divided by that. So you just write it as generally as you can, because now I've written a point that represents actually this entire freaking thing. There it is. That's a representation of this whole thing. I like it. So instead of doing this, we could have actually done all of our functions like that. Thank God we didn't. Well, could have been the same. Who knows? And I want to know how far away from 30 I am. So what would that look like? And I think we talked a little bit about if we minimize the square of the distance, that means we've minimized the distance itself. Thank God. I don't want this big ass square root hanging over my head. So what is the distance formula?
X minus 3.
Yeah, it would be the difference in the x's squared plus the difference in the y's.
Y minus 0.
All right, let me stop there for a second. Pretty much every problem that says, what's the closest this gets to this? In this case, it's a point, but it could be another function. And then I would just write a general point on that function like I did this, and then I would create the distance formula, and then I would take its derivative. I mean, that's the process doesn't really care. You want to get close to something, you want to minimize the distance, there's the distance formula. What do you probably want to do? Yeah, we can take a derivative right now. I mean, you could. What is this?
64.
Yeah, we can just leave this as is. I don't need to multiply that out because its derivative is pretty easy the way it is, right? No? Yes? Maybe? No?
Yeah.
Sure, okay. So then d squared prime,
2x minus
yeah, 2x minus 6.
3. Minus.
No, you gotta now remember, this is where it's going to be painful, actually.
20.
You're not integrating, you're differentiating, right? Take the derivative. I like it.
128 over x cubed.
Yeah, because it'll be, then 2 will come down, and it would go to the negative third power, right? So it'll be 128 over x cubed. And that gets understandably difficult, where you got to really remind yourself, am I integrating right now, or am I differentiating right now? And what do I do with this? Yeah, if I'm trying to minimize the distance, I take its derivative, set equals 0, find the critical numbers, find out where it could be closest, right? Now this gets interesting, and I want to remind you guys about something that didn't really come up this semester. How do I proceed with this? No, we don't know. We were just hoping to keep going, Jeff.
1 denominator multiplied by.
Yeah, well, what's the only bad thing? What's the fraction?
X cubed.
Yeah, so multiply by it, so there's no more fractions. So you can divide by 2 at the same time. Is that cool?
Yeah. Sure.
Again, I gotta go back to, am I here? Are you here? Equals 0. Now look at that. That's yummy. Now, John, you had an interesting way to attack this, and I'll bring that up in a second, but I want to remind you guys about synthetic division. Does anybody know synthetic division? You should have learned it in pre-calc. You should love synthetic division. It kicks so much ass. My Math 90 students probably wish they knew it, because they have to do long division of polynomials the old-fashioned way. Back into this, and oh God. So synthetic makes that nice and quick. Right? How would it help me here? Because synthetic division is actually a very powerful factoring tool. What's the only kind of things that this could factor into if it could?
X cubed.
What numbers could be at the end? So could x minus 7 be a factor of that? Hell no, because 7 doesn't go into 64. So then I could try x minus 2, x minus 4, x minus 8.
X minus 4.
Yeah. So the 4 is going to work. So I mean, just to remind you guys, so if I do 4, here's synthetic. 1, negative 3, no x squared, no x's, no webbies. There you go. And then you do 1 times 4 is 4, plus, multiply, add, multiply, add, multiply, add. That's so freaking awesome. So then this factors to be x minus 4 times x cubed plus x squared plus 4x plus 16. Does that look at all familiar to you guys?
Where'd you get the 4 again?
I guessed. I could have used 2 and it wouldn't have worked. I could have used 8 and it wouldn't have worked.
And then would you try to do synthetic division again on the bottom piece, or is that just...
Why do I know this is not going to go anywhere? Let me see if you guys are cool with this. Well, let me say it like this. This can't have any useful... I know it's going to be over here. I know the answer is going to be over there. So I know x has got to be positive. This can't possibly have any positive roots. And you're all like, sure, make a statement like that, Jeff. But I mean, what does this look like? This looks like x cubed plus x squared plus 4x plus 16. The only possible value of x that can make this equal 0 is a negative value. Any positive value of x is going to just keep adding to itself. It ain't never going to become 0. So, but you're right. And if I wanted to keep going, I could just try 4 again, or maybe it keeps going. Maybe that's as far as it goes. I don't know. Shit. I don't care, because that's the only possible positive root. So 4, it must be at 4, what point? 4 comma 2 is the closest that gets to 3, 0. Very useful. If you can extend this to 3D, and then you're talking about how close your aircraft, your spacecraft is going to get to some radioactive meteorite thing, asteroid, you got people on there, and, there could be a whole new movie in 10 years. Remember that thing that happened in 2018? Shit. Sorry, I went off. But you can talk about what's the closest approach. Are we going to survive that? How many REMs are going to come through our freaking craft? We want to know what's the closest approach based on our trajectory right now. That's exactly the math behind that.
Does anything change because of the d squared?
Not really. No, I mean it's I can calculate the distance now, right? Because now that I know the point, I can calculate the distance. But nothing changes mathematically here, because if I find what x makes the distance squared minimum, that x must also make the distance minimum. That's why I didn't have to leave the square root in there, thank God. It would still work if you left the square root in. It would just be remarkably disgusting. The math would still work. The math wouldn't have a problem. We'd have a problem.
The distance one was just like Pythagorean theory.
Yes.
With x, with the change in x, change in y.
Completely based on Pythagorean. Change in x is just one side, change in y is the other side. The a, b. Yeah. I like it. Alright, so that's that one. And that's a problem. I'm not saying anything necessarily, but I love those kind of closest problems. So maybe it's got a decent chance of showing up on the final, that kind of problem.
How do you know what to divide by? Like the 4? How do you just choose one close to 3, or?
No. How do you mean? Right here?
Other 4.
Here! I just went to the one I knew was going to work, but I could have used, what could I use? 1, 2, 4, 8, 16, factors of 64. That's the only possible things that would end with a nice number at the end. Yeah. Okay, cool. I like it. Oh, real quick. John had a cool way to do this. He didn't factor the whole thing. He just factored the first piece. And then you can sort of see that if x is 4, this is 1. So 4 cubed minus 64 is 0. So you can just kind of see that it's 4 if you get kind of lucky to realize that's what it is. But this is the way you could actually calculate what it is. I like it. Okay. Let's see. Where are we at now? 54. Oh, yeah. 54 is the one about the cone. The largest cone that could be inscribed in a sphere of radius r. So you got the sphere. And let me see where so the spheres of radius little r. And I want to inscribe some cone. Actually, let me go ahead and just do it the way it's going to be most helpful. Alright, there you go. Yeah. It's alright, just let it go. So that's inscribing a cone inside of a sphere. I like it. So in order to attack, and I'm trying to volume of the largest circular cone. I like it. So just like if they told me, so if a different problem said, I want the surface area to be this, find the largest volume. Okay, the surface area would be my restriction. That restricts the kind of cones I can make. They have to have a surface area of this. So the fact that this has to live inside of a sphere of radius r, that's my restriction. So it works the same kind of way as if they gave me a physical piece of information. The surface area is this or something. So what they tell me is it lives inside a sphere. I have to get from this, I have to get something about the cone itself, of course, so I can write its volume in terms of the sphere. So what do I need to know about a cone to get its volume? What's the volume of a cone? 1/3. The circle your base times the height. So I need to know its radius. Let's call that big R, just to differentiate between them. Alright, so I need, so this is the steps I would take if I was given this problem to do. is I draw what they told me, right? That's because that's the restriction on things. And then I write the formula that I know I'm going to have to work with, right? This is what they tell me, this is what they ask me. And then this tells me what I got to find. So I need to figure out how to write this. And I also need to figure out how to write this. Don't go too far. Now, unfortunately, neither one of those are directly related to R, not quite yet. We need to work that out. But what do you guys see that might help me here? There is something related to this that is remarkably related to this.
Radius.
This
So radius.
is
Radius.
R, right? Isn't that the radius? So the height is equal to this piece plus the radius. So let's call this piece, what are you going to call that?
X.
I'm going to call it Y. Probably because it's Y, because it's on the Y side. So I know my H is R plus Y. Some of you guys might be like, you didn't do shit, man. You still got to figure out what the hell Y. Okay, that's nice. But at least I took this part out of it. That part doesn't really matter anymore. So what can I use here to help me get now I need a relationship between all these things. So I don't have H anymore, I have R plus Y. So if I can get a relationship between big ass R and little old y, I can replace one of them. Yeah, how?
Y over H.
R plus Y over H? No.
So what are you using? What do you see that we can use? Are there similar triangles? What's going on?
Is there Y over H and R, small r over R? Oh no. Big R over R small. I mean,
So you got to make sure that it works. So you're saying, well, Y over H. So like,
That's
oh no.
it's not quite.
H over R plus Y.
So let me make sure everybody's understanding what we're trying to do. If we can find similar triangles, that kicks ass. So we've done that kind of thing before, right? I do see this one big old triangle here, right? Don't know this, and which means there's a little triangle here, but are those really going to be helpful? Well, yeah. Because so for this big ass triangle, what are the side? What's this side?
Well, Y plus R.
Y plus R.
Over big R. And then Y over big
So that's the big stuff. This big stuff.
Y.
Y plus R over big R.
Y over big R.
No, you can't do the butt end. So then I have to know what this is. So that gets a little troublesome, right?
so little r, and could we just put a new variable?
Say it one more time.
Would we just put the little r as the height for that little triangle, and then would we create a new variable for since we don't know what that specific length is?
Oh, no. Oh, God. You don't want to make a new variable. Yeah, we're trying to get rid of the variables we already have, right? So I'm in a sphere. So what's that mean, Jeff? I don't know. So I've got my coordinate axes there, right? And the sphere goes through, but I can look at a cross section of it, for example, maybe. Which means that isn't this going to be y then?
Yeah.
And so this would be x. So this point would be ry. Okay, cool. I like it. So it's trying to get you guys to go through and realize that maybe the triangles won't help us too much. But what's the relationship here? The fact that it's on this circle. What's got to be true about it? It's on this circle. What must r squared, big ass r squared plus y squared, what must that be?
Little R. Little R.
Little r squared, yeah, that's the radius. So then you know that big ass r squared is little r squared minus y squared, for example. So you can replace little big R squared with that. That looks helpful.
Yeah.
All right. I mean, the more examples you see, the more you realize you're allowed to do. So the one thing I didn't use was this idea of that point sits on this circle. So that is another thing I can use to my advantage if I wanted to. Okay. So, I mean, once you get that, once you know this is true, you plug that bad boy in there. What's my only variable going to be?
Little r.
Y. Exactly. Because if I make a different cone that's more fat, or more stocky, then Y changes, doesn't it?
The r is constant.
Little r is the radius of the sphere it lives in, so it doesn't change. I'm not letting the sphere, that would be a whole other problem if I let the sphere kind of like grow or shrink. I like it. So now the only variable in this whole side is the y variable. I like it. So now you can attack this with, you could multiply this out if you wanted to, or do product rule here, right? Because I'm trying to find the...
Isn't it the square root of r squared minus y squared?
No, because this is r squared.
Oh, I didn't see that.
Yeah. So that's awesome when the problem has a square on it already. You don't have to square root. So that's another little thing. If I have a choice between something that's squared and something that isn't, and I have this relationship, I'm going to obviously choose the one that's... I just replace that directly. I don't have to bring square roots into it at all.
Are we going to have something that abstract on the final?
Not like that. Yeah.
Yes.
It might be a little bit more obvious. That one was not the most obvious. I agree. Let's see. Oh. 58 we did already. Hopefully you guys are cool with the fact that, I mean, this should be...
Yeah.
I mean, you should just be able to attack that now. It's getting here that's the problem.
Do you need to take a derivative or anything like that?
Totally. That's the next step. Because I'm trying to maximize the volume. So I got to find this guy's critical numbers. Yeah. So you have a choice. You can multiply this out, or you can just do product rule here, whatever you want to do. Let's see. Blah, blah, blah. 13 goes... Where are you at?
Just multiplying it out, like foiling it out, would be easy, right? Because it's a minus and a plus. So it'd just be r cubed minus.
Well, but they're not. You still get. Yeah. Actually, yeah, you're right. Yeah. This has got r minus y, r plus y in it. So yeah, cool. So then multiplying that out won't be too bad, and that's just a constant. It could just come for the ride. All right. 457. What were these? Oh yeah, these were the rotations. Let's do one that's got like a. I don't think. Let's do one that's got like an axis that's not the y or x axis for rotation. Did I sign that one? Yeah, like number 10. And so we're doing number 13 on the practice final, part number 10 on page 457. So it says, this is the region we're talking about. Oh. This, do you guys realize I've given you this problem many, many times? I don't know. An up parabola and a down parabola. That's a classic region, a way to define a region for rotation. You got a down parabola and an up parabola. They're going to meet somewhere, and it's well defined. Where'd it go? About y goes -1. That's our rotation axis. So very quick, down and dirty sketch of this is going to be, this opens up, and this is at 9, and it opens down, and I just need to know where the intersections are so I can define my limits. Yes, sir?
Set them equal to each other.
Beautiful, right. We've done that plenty of times. So it would be 2x squared minus 8. Is that cool? Just adding that, subtracting that. Divide by 2, you get 4. Take a square root, then plus or minus 2. I messed up. So I don't have to graph any more of the function than that So some of you guys are worried about getting the whole thing on that problem. I just care about, once you find out where they meet, only graph between those 2 points. Who cares about the other parts? Right? That just gets in your way. So what method am I going to use to do this? Where's y equals negative 1? What does it look like? Uh-oh. Yes. Horizontal line. I like it. So y equals negative 1 is there. So if I say I want to do shells, it would have to be integral d what?
Dx, dy.
dy.
Only two options.
Yeah, disk agrees with the axis you're rotating around. Right? It's parallel to the x-axis, so disk would be dx. Shells would have to be dy. I like it. So is there, one thing is these are already solved in terms of x. So I can use disks. Right? Plus shells would so desperately suck, because right here you'd have a different integral. I don't know if you guys see it. Right at this point, a different function takes over. I'd have my rectangles laying down. And then have to change right there, a different interval will take over. Screw that shit. Holy crap. No, thank you. So if I do disks, what do I have to figure out? What form is it going to be in?
Inner.
Yeah, I need the outer radius and the inner radius. I like it. And really, it's just going to be the function increased by